This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome back to Mastering Mathematics, program sponsored by the Ministry of Education and the EBU, Education Broadcasting Unit, and ABS Television. Our aim is to make certain that mathematics remains a public education and that the nation of Antigua-Barbuda gets out of this syndrome of thinking that mathematics is a difficult subject. Because by now you're saying that is something of the past, because there's nothing could be further from the truth. What are we doing? So we did last night, we went into the vectors, so you know coordinates, you know position vector, we know parallelism, and we know the triangular law. And what is our triangular law saying? It's saying that the resultant is always equal. The resultant is the one that's going in the opposite direction, and the sides would be the vectors which are going in the same direction. The arrowhead on the lines would tell you exactly what is. And when you want to ask about saying going in the same direction, I used to tell my students, you know, when you have children and they're holding each other on the shoulder and they're pushing one another, so you have two going in this direction, and then a friend is coming in the opposite direction. The friend coming in the opposite direction is the resultant, and these two that are going down the road singing the little tune, like what you do on Juve when you're in that band and you're holding on to each other, you're going in the same direction. When you say the rude boys are coming in the opposite direction, they are the resultants. And we who are dancing going in that direction, we are the sides. All right? So we have it from all directions that you can tell yourself what you mean when you say that. On the triangle over here, we can see it, that if we had to ask you which is the side and which is the resultant, because this, so you see that this is going in to fit into this, and this one would be coming in as if we're going to put up two noses meeting each other, then this would be our resultant, okay, the resultant. And this would be a side, and that would also be a side, okay? Because they're going fitting into one another, and the 2 points are coming back to meet each other. So AC would be the resultant, and AB and BC would be the sides. It is important how we call these lines, because you can't say in terms of vectors that if we say BC, that it is the same thing as CB. No, because we would have been going, so CB would have been going in the opposite direction. So that in terms you were saying BC would be equal to negative CB. And we can see that because if you're walking and you're going BC to go CB, you'd be turning back. All right? So BC is not the same thing as CB. So please note that. Remember we said already, vector has size, so it had, and position. It also has direction, okay? So please note, how do we know what to call the sides? It is the direction in which the arrow is pointing. So we start from the bottom here going up, and it is called, so this line would be called AB, okay? AB. Now we could never talk about an AB. It is not the same as BA. AB and BA would only be equal because AB would be equal to negative BA, all right, in the opposite direction. So please note that. The line is called BC because the arrow is going in that direction. CB is not the same as BC. It's the opposite direction. So we have to get that clear. Now, suppose we were given a chart like this right here, and then we were asked, because we're going to look at some of the problems now, we were asked to write these in as a column vector. we're asked to write those as a column vector. What would we be doing? The first thing we'd want to tell our students is that if you can't see it naturally, we'd look as if we had, because where they're starting from, where the arrow starts from for the vector, it's usually the origin, because a vector has to start from a position. So you could look as if you're drawing in an imaginary x, y axis and your x axis, because you want to see what is happening here. And if we had to do this here, we would notice right away that this is on the opposite side of the y-axis, and so it is going in a negative direction. Okay? So right away, our horizontal movement would be not going right, but going to my left, right here on the board. And how would we be walking? So again, don't forget we have our nice square, thanks to Mr. Ezra. And we'll be going over, so we'll be coming to 1 centimeter, but it is a -1, okay? -1. Then when we get there, we want to catch the head of the arrow. What do we have to do? We have to step up. And if we had this labeled as a 5, as we said, for 5 centimeters along the y-axis, then we would have been going here again and stepping up to 5 centimeters here. All right? So it's just going up and we're stepping up here, so that this then would be, let's just give them the same axis this time, because I want to make something to say. You're stepping up 1 step. That's what I want you to say. So that would be 1. So for this particular vector, our A then, for A, the coordinates, the position vector, OA would be equal to, our horizontal movement took us over to -1, and then we had to step up, and how many steps were we going? It is 1. So that was equal to 1. So that then would be the position vector for the A that we were given, for the vector A that we have on our chart here. The other one that we have, we're looking at B. And let us look and see. For the vector B, what would be our column vector, because so it's the position vector OB that we want to see. And if we can visualize, again we are seeing that here the axis would be coming, putting then our vector on the opposite side again of the y-axis. So we're going in a negative direction. So let's just put in this here. Okay, so here. Okay, and the horizontal position here. Okay, and that's in a negative direction. So again, we'll be starting from O and going over. What are we going? So we're stepping out, and it is -1. So again, for B, we can write that the coordinate here would be -1. And in terms of catching the vector, the arrowhead, what do we have to do? This time we have to step 1, 2 squares, so that the Y position would be 2. Okay? And so the column vector for OB would be equal to -1, 2. -1, 2. When we look again at C, we can look and see, so what is happening here? And if we put in again our imaginary X and Y axis, so we have horizontally, and then it is going here again, where it would be vertically. So that's our y-axis, and this is the x-axis. Now where are we going? This time we are going still on the left-hand side. So we'll be moving from O, and it is stepping out 1, which is a -1. And where are we going again this time? We are stepping down. And anything beneath the horizontal line it's a negative value for our y. Okay? And how many squares are we going down? How many steps we're calling them? So it would be 1, 2. Okay? So that C then, OC, the column or position vector for our OC would be equal to -1, -2. That is what we're getting. Now look again and see what we did. So we put up the horizontal axis, and then we put up the vertical axis, and we say, where is it positioned? How many squares do we have to count to get to the arrowhead? So when we walk, first of all, our first movement is the horizontal. We had to come over -1, and then we were stepping down to meet the arrowhead, and we had to come down, and we know right away beneath the horizontal line that the value of our y would be negatives, and so we had to go down to -2 to catch that arrowhead, so that OC is equal to -1, -2. Then we come to the vector D, and we want to find position vector OD, and we're saying OD is equal to, and now I'm sure we have first set it, that we can use it. We can say, yes, this is where the vertical line would have been coming. This is where our horizontal line is. So we do our horizontal movement first. So from 0, it would have been 1, 2. So it's a +2 for the horizontal position. And then to get to the arrowhead, once we're here, we say, how are we going to catch you? We have to step 1, 2. So we have to step up 2. So then that is 2, 2. And that is what we're doing with our column vectors. And then we come lastly to our OE. All right. What do we see that we have here? And for OE, we see we are on a flat plane. So what are we doing here? So we are walking 1, 2, nearly to a half. So we're going 2.5 in the horizontal position. But when it comes now to go to the y, we don't have to step up anywhere. We don't have to go up nor down. So what is the value for that? That is just 0. Okay, we didn't go anywhere, still in that horizontal position. And that is what we have to do to work those problems and to get the column vector when we are given this, where the question would have been saying, write these. So given these single vectors, to write them as column, to write the column vector component or their position vectors. Easy, right? So you can get your graph paper now, and don't say you're waiting on the teacher to give you any exercises. You're sitting and you know they're in your mind, so you just give yourself some and just start drawing them and say, what would be the answer for this? What would be the answer to this? Some of the best teachers are the person who can teach him, herself. All right? What are we going to do for ourselves? That's the whole position now. We are going to teach our students that the textbooks, they're somebody else's idea. And we are now not using a behaviorist curriculum, but we are using the constructionist one, where we are actually creating the knowledge for ourselves. And that is what education is all about. That is what our colonial masters didn't teach us. And that is what Karen Weston is going to bring to the Antiguan people, to let you understand, no, people are not born to make or to write books. We discover our information and we write our stories. And each person can create his, her own textbook. The primary school teachers students have shown us this in their projects, and that is what we want to perpetuate for the 21st century, that we are the creators of our knowledge. We are mathematicians. We were born that way, and we will continue to make certain that that becomes a focal point from which we are working. I'm going to give you a time to take a little break, and then we will come back and show you how you are using the rule for triangle before ending and talking about the projects for the primary school.
If you know the answer to a question is incorrect, and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read my problems completely before beginning any calculations. If you glance too quick at the problem, you may misunderstand what really needs to be done to solve the problem.
Right, so we're back and we're going to make certain that we make you mathematician giants in this country and in this world. It can be done and it will be done. And I'm calling upon my grassroots people to come and take in an education, because our parents and our fathers with a little crocus tie around their waist showed us what it was to acquire an education. Forget about the capitalist trappings that you think that are driving you. You must have material goods are not important. Wisdom and understanding and the knowledge of God is what's going to guide us. All right? The last part I want to just devote to this little part here to show my performers again and the adults how we use the triangular law, and then get right away to my primary school students and teachers to put their hearts at ease for the upcoming grade 6 examination. Okay? Now, suppose we're given a question. How do we use? And next week, I'll take you into collinearity and go straight to the examination papers where you will see what the vector questions are all about. Ratio and everything and dividing them, sending you on the website to make certain that you can get them. The CXC website has a lot of them, so you can go and get your exercise, and you can always ask your teachers and phone me too, because the questions are too simple, too easy. All right, somebody has really done us an injustice to tell us that mathematics is so difficult. Here we are. Suppose we were given the vector, the coordinates that we had, E, and it's equal to 1, 3, and I've drawn it out on the diagram here, and that S is equal to 2, 2. All right. First of all, they have now asked us to find for them the vector, and what do we want to say? They want us to find for them the length of the vector, and I'm going to just put it in here in dotted lines. So they would want us to be asking, what is ES? So I've drawn it in that position. Okay, and so we have to find the line, okay, line ES. All right. Now, so given the vector and with the coordinates, given the coordinates, E is equal to 1, 3, and S is equal to 2, 2, find, because this is what we are asked to do, find the vector ES. So the first thing we have to do is to translate, put it in a form again as usual, put it in the vector form, so we have to make the coordinates into column vectors or position vectors. So we will be stating, first of all, since E is equal to, and it is 1, 3, then OE would have been equal to column, and it is 1, 3. Similarly, we can say since S is equal to the coordinates row vector 2, 2, then OS, which is the position vector, would be equal to column vectors 2, 2. All right, we would have to take, so, and you can do just a little quick sketch. It doesn't have to be in any proportion or anything. So you're writing down, we have O, you have E, you have S. put on the arrow so you see where they're going. Okay, and this is coming. Because your first task is to identify which is the resultant. Okay? And we're looking. And so you're saying, this has to be a side because it is going to fit right into the back of this. And the nose of this one is going to bounce into that one. So this is my resultant. So OS, you're saying, is your resultant. This is the side 2, and that is the side 1. All right? So what do we want to find? We want to find ES. So what is ES? ES is a side. So if we have to find a side, what do we say the formula is? We are saying that side 2 would be equal to our resultant minus side 1. So that we can put in to say side 2 here represents ES, and that is equal to the resultant, which is OS, and it is minus S1, which is OE. All right? All we're doing after that is substituting our values. See, we have OE here, and it is OE is equal to 1, 3. Okay, the components, 1, 3. And OS is equal to 2, 2. And what again are we doing? Using the same tools for mathematics. It is no subtraction. And in terms of the vectors, the things in the same positions are subtracted from each other. So let us put it up here high where you can see. So I have 2, 2, and it is minus, and it is 1, 3. And that we say would be equal to 2 minus 1 would leave us with 1. And this is 2 minus 3. Which number is bigger? The negative 3. So then it is bigger by how many? And it would be 1, so it is negative 1. All right? So, because I could show you that this would have been equal then to 2 minus 1 and 2 minus 3. And that is how we got this answer here, where the answer would be 1, negative 1. So therefore, we can say that our ES, the vector ES, is equal to 1, negative 1. And that is how we use our triangular law to solve for any of the sides, or if it were a resultant we had to find. So we're going to stop here with our vectors for our performers and ask you to check your books, check your past papers, go to the website and start working some of these questions. Next week, I'll be telling you about the property that we're calling collinear, and I will show you something again, how you divide lines into sides using the examination papers. So for now, it is time to talk to our primary school teachers and students. Now, normally we know that we have added the mathematics component, and we call it the project for the 11 plus exams. Nothing has changed. There is not a set pattern. The set pattern comes from the fact where you're going to be talking about, you would give us an acknowledgement, you would tell us what your project is, you would give us the method, you would tell us what was your result, you would say what have you learned, and how will this be able to help you in the future. Anything like this you're talking about. If you use any picture from the internet or any references, you will have to, or anything, if you use any pictures from the internet, quotes from any other book, you will have to reference them. So at the end, we're going to see a bibliography, all right? Teachers, you can look on the website and you can go and you can see the Harvard or whichever one you want to use, but just make certain that you are consistent. And that is what we're doing in terms of the project. I told some people already, because when we started in the beginning, this was a very new idea in terms of the whole novelty of saying introducing a project. Yes, I did give people I am writing and information about what a project is, because Mr. Halliday from Barbados had done something like this, and I was made aware that it did exist. It was on the back shelf of something, because in the Caribbean they were not buying that idea. But again, Antigua, my having been to India and seeing how these things can work, came straight away, and we went into it, gave our teachers a year to make certain that they could sensitize themselves with the whole notion of projects and see that mathematics is not something that stays in a book, but is actually a tool that is used in the workplace. And how and where are we using it? Okay? Therefore, no teacher, I as the education officer for mathematics cannot be telling you this is the topic I want. I love St. Nicholas's School because they're always coming up with something so innovative, so new. We get it again from the Baptist school. We get it again from plenty of our government school. But these children from Newfield talking about the school meal plan, coming up, and people are talking about they don't have any manipulatives to work in the classroom, and students are just making these things. That is what we want from the projects. Not Karen Weston saying, all right, they say your projects will come. No, we want creativity. We want people to be guided. We are now in a constructionist mode. We must create our own knowledge and our own information. So it's you teachers and your students who are going to come together and make your project. The last time I was so very proud when a little guy from Foundation Mixed School he came from, and he started talking about his father's business, wanted to see if there was efficiency in it. And you don't want to see how proud that little guy was, dressed in his suit and on that picture, lovely, discussing, giving out his little survey. I had also from Sunnyside School, I had Tarek coming up with a project showing you how ratio is being used. We had also students from the other departments. St. Nicholas coming over and saying, oh, so it's the Olympic year. Right, let us not do angles. All these people that have to do all these things, the different moves, the testalons and everything. What are the positions? This is the way. I want them to do something like a toy. Okay? Stop making it a remedial aspect of it. No, it is not that. They would have been taught mathematics, and you don't want them to say, how am I using it? And how can I forget Pearce Secondary, where Shaka has done such a brilliant thing. Little Bethesda, lovely book. And up to now, they can't get them back from me, you know, because I'm going to have an exhibition, and you will come and see. Let the children have imagination. Can you believe I have schools located so close to the Deepwater Harbor, and you don't even ask them to say how many ships have come into the harbor? In which months do you see how many ships coming into the harbor? All this, we have Mary E. Pickett sending the students around, asking, what is the famous color? What is this? Make it be exciting for the students. It's not a time to sit down and to talk about, okay, let's give them some sums because they can be able to do the second part of the exam question. You're supposed to teach them that in the classroom. Let them have fun now with the project. We get so much innovative things and things that people can learn from. Barbuda sending over and seeing that most of the children you're calling Barbudans, they were actually born in Antigua. How is that going to go when you talk about possession of land in that country? These are the sort of little things that are coming out, all right? And that is what we want to make happen. So do not make it any boring stuff for the students, giving them and talking about they have to say, okay, do a fraction again, and this is the thing, and this is the chart stuff. Get out of the classroom. Take them into the environment. You didn't want to see the nice little houses some of these children are building. That now you see them taking up the ideas in other countries and running with them to see what is. Many of the projects we're seeing here in Antigua would give any mathematics department in the University of Nottingham a run for their money. The days for saying your cogging is finished. It's all teamwork. I go to my mechanic, and as soon as the bonnet is open, you don't know where they come from, but you just see three men drawing together. That is what we are about, okay? And that is what the project is all about. Remember, you are the first markers. I will see them when you're finished. And the parents who help, thank you so very much, because that is how you get collaboration. That is how you get unity. That is how you get a family spirit coming in, because it's a we thing when it comes to education. So we're going to make certain you know those terms, you know which mathematics operation you have to perform. Keep on studying, keep on working, and only hard work pays off.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.